I'm going to make a few assumptions with this demonstration. And what it comes down to is, you can give entire talks on these assumptions. So first of all, some malicious action is capable of taking place on a computer. So someone has either exploited a whitelisted application in order to run their malicious code, or they've hacked directly into it, so now they're able to take control of it and directly modify it, stole credentials from someone, RDP directly in, and now they have control over it. That's the first assumption. The second assumption is they're able to gain administrator rights through some account. So they're either exploiting an application that has those rights, or they've hacked, they've managed to increase their credentials to gain that. And then the third thing is that user account control isn't going to be something that stops them from performing their actions. So the demo I have for you is based on those assumptions, and I will show you what we're capable of doing. So I have loaded for you a VM, and hopefully it'll cooperate for me. So inside of this virtual machine, I've installed an application whitelisting product. And the intention is not to pick on a vendor, so I've basically hidden any reference to this particular product. What I've done is I've installed 2 legitimate applications on it. We have Procmon, a sysinternals tool. So if you were going to look at this from an outside perspective and you didn't know this was a good application, this might look really suspicious. It's capable of monitoring what sort of activities are happening on the computer. It's capable of recording that, tracking it. So, from an outside perspective, that might look malicious. Similarly, and you'll see that this is allowed to launch. Similarly, there's this cross-loop application, which is a means of RDPing into a computer, essentially, to take control. Again, from an outside perspective, if you were looking at it, it might appear suspicious. What we've done here is we've said, okay, I want these things to run on my computer. And the way I'm going to allow these to run is I'm going to register their certificates with the application whitelisting product. And what that certificate does is it says, okay, this piece of signed software is allowed to run on the computer. And the reason they do this is because it makes it a lot easier to manage an application whitelisting product. Because if you have to know every single executable that runs in your environment, it's a management nightmare. But if you can say, okay, I trust all certificates from Microsoft, or I trust all certificates from Adobe, it's a lot easier to manage the solution. Yes?
Why would you assume that, considering that Adobe and Microsoft in not too recent times have both had problems with certificates?
I agree entirely. And that's kind of what I'm getting at, too. And I'll go into more depth on that a little bit later. But yeah, that's one of the problems. Making these assumptions is particularly problematic. So we have these legitimate applications we're allowing to launch in this particular instance. Now what I'm going to do is have this application over here. Let me hide that. Okay, so we have this fake malware exe. So if I try to launch this, you're going to see that it tells me that it does not have access rights to it. If it will hurry up. And the reason it doesn't have access rights is because this particular application isn't known by the application whitelisting solution. There we go. It was hiding. So it says, Windows can't access the specified path. You may not have appropriate permissions to access the item. So we can't launch this application because the product doesn't know about it. So if this is malware, it's done its job pretty well. Again, I have another malicious application. Again, won't allow it to run. And that's despite the fact that this fake malware even comes with a certificate of its own. So on this, I've attached a digital signature from the fake malware cert, but because it's not a trusted certificate provider, the product's not going to allow it. Now, the issue is measures can be taken to subvert this certificate authorization process. And what I'm going to do is demonstrate an exploit here where I'm going to point this application whitelisting product to a fake certificate store I've created in order to perform an exploit. So first thing I'm going to do is I'm just going to move the certificate for fake malware.exe into this fake cert store. So at the moment, I haven't engaged any of the capabilities yet, so it's not going to be allowed to run. It's still going to get blocked.
What is a fake cert store?
It's certificate store. It's where they store certificates.
On the local machine?
Yes.
Okay.
So it says you can't launch it. And then what I'm going to do is I'm going to execute one registry command. Since application whitelisting isn't designed to block any sort of registry modifications, this is going to be allowed to work. So now, in order for this to take place, I just have to restart the computer. So I'm going to restart. Now, the reason these types of exploits work is because application whitelisting products tend to need a local storage mechanism for their certificates. Because if you don't have that, then you're in a situation where either you lose network connectivity and it nukes everything on your computer you wanted it to run, or you're allowing everything to run on the computer in those instances and you created a new exploit that malware developers can target. So by keeping it on the local system, they're able to prevent that sort of hole. But because we can leverage existing changes to change where it looks for those certificates, we can trick it. So before, you'll notice that proc monitor and crossloop would work successfully. Well, their certificate is no longer in the legitimate certificate store used by this application. So when I go to launch it, now all of a sudden I can't launch process monitor. If I try to launch crossloop, I can't launch crossloop. And what this allows a malware developer to do is do a denial of service attack. So if they want to, they can basically neuter your computer and prevent anything from running on it. And to you, it's going to look like your application whitelisting product just completely freaked out and did something wrong, so you're going to go on the forum and swear about it. In reality, what's happened is malware's managed to change the way it's working. So what we can do is we can, go to our fake certificate store, and we can. And then the other one. We'll move these legitimate certificates into our fake store, and now all of a sudden you can launch it again. So you don't have to do a denial of service attack. That might be caught. That's something they can see. Rather, you can do something more subtle. We take that out. We can prevent a specific application from running, maybe one that we don't want to run because it provides some sort of security technology. Or we can allow everything to run and make it appear as though it's working properly. But all of a sudden, our fake malware exe, because we added the certificate to that fake certificate store, is now allowed to run on the computer without any sort of issue. So from your perspective, it looks like your application whitelisting product is working perfectly, but now I have complete control over what software is going to run on that computer, whether it's malicious stuff I want to run, or whether it's legitimate applications I don't want to run. So that's our first exploit. And as you can see, the one I didn't permit still being blocked. So that's essentially the first compromise I have, and that's the certificate exploiting mechanism by taking advantage of the reliance on these certificates to allow software to run. Does anyone have any questions on that?
Web entry just repointed or redirected where your cert store was? Is that
correct?
Right?
Yeah, it was a technique.
So why didn't you just copy the cert into its current location?
Because most application whitelisting products are smart enough to protect that store, but most of them are not sophisticated enough to detect the fact that you've changed the location to which it points. So I've managed, there are 3 or 4 different ways to actually do it in this particular instance. It's a little hackery with junction points. So that's our first exploit of application whitelisting.